morbid obesity, over 400-pound patient, intubated, installation of the Palma Vista, the electrical impedance tomography, currently on AC VC, had a PEEP set at 10. We did a PEEP trial from 10 up to 20, and we're going to verify and see the results of the PEEP trial. So this is just to get a perspective of the size of the patient. This is the distribution of ventilation. We see that there's ventral to dorsal. There was 30, 43, 19%, and 8. Since we've been doing the PEEP trial, we've had a loss in the ventral area because it's been redistributed more to the mid-ventral region, and bring these numbers lower so that we have more distribution in the gravity-dependent regions. We put the larger screen to get a perspective. So don't forget, this is a caudal to cranial view, right side, left side, sternum, vertebrae, ventral to dorsal, anterior, posterior. So similar perspective to CT scan. We realized that it says 8%, so when you're below 10%, this doesn't really appear blue, but it doesn't mean that there's zero ventilation. It's just that it's very minimal. We look at the white section here, which shows the maximum distribution of ventilation to that area, and we want that white area to be well spread out. It's a quick way of looking at evenness of distribution. If it's well distributed, the white inside the blue, that's good. If there's areas where there's more white intensity, it's telling us clinically that more of the ventilation, more of the alveoli in that section are taking the brunt of the ventilatory power. We see that when we try and recruit with higher PEEPs and are not successful, that a lot of the times the white intensity will be trapped in the more ventral areas, in the non-gravity dependent areas, and that's not optimal. If we can manipulate and individualize the ventilation with guidance through electrical impedance tomography, it's a great way of not just having to rely on global values that we see on the vent, plateau, drive pressures, etc. We can then rely using also that information together and have regional distribution, literally eyes inside the lung. And when you pair those two, all this information together, then you know that you're in a good section. So you notice this turned purple suddenly. That was just because one of the staff was touching the patient. You'll have interference. It'll show up purple. All right, I did a previous PEEP study from 10 to 20, and initially the ideal PEEP was 14. Then after I noticed that during the recruitment phase over here, when you look at the trajectory of the impedance curves, more impedance means more tidal volume. So you notice here at 12, 14, 16, they're holding pretty straight. But at 18, you begin to have a increase in impedance. And this underneath represents your functional residual capacity. We went further up to 20. This obviously 20 is not optimal. It seems like 18 over here would be the most optimal PEEP for this patient. And don't forget, as distribution varies, what might be optimal in the initial phases, if recruitment does occur, it doesn't mean that that is the optimal PEEP. It may be lower. So this is the image at the end of inspiration. So we want to see, comparing the PEEP as we go up in the PEEP, at the end of inspiration, is it opening up some of the areas. So this is looking at end inspiratory trending. Down here we see the staircasing of the PEEPs. We're seeing the peak pressures, and the volumes are maintaining themselves straight because we're in ACVC. And we can put the reference over here, and we know where we are time-wise and parameter-wise, percentage-wise of the distribution that we're looking at over here. And we have the control that we can scroll all along the time axis and look at varying PEEPs over time, what are we exactly seeing? If we're seeing any gain, it'll show up here. It's this compared to this, and blue will mean there's an increase over here compared to there. So we're gaining in the mid-ventral area, not exactly where we want to ideally gain. We rather have more 3s and 4s, but it just means that there's a slight shift in the distribution in the ventral areas, a little lower to the mid-ventral, which is still a good thing. I rather get less volume in the ventral area, and keeping in mind here, let's go over here, we're going up to 20 over time, and you notice here this is recruitment of functional residual capacity. This is becoming more and more air, generally over here. Okay, so as this is shifting, again, the PEEP studies should be done a couple of times as things are recruiting, maybe one at the start where you get some recruitment, and then over time when the impedance curves flatten out, it shows that there's no additional recruitment. Therefore, we should do another PEEP study before leaving. We want to do multiple times to make sure that the results are reproducible. We then go to this screen here, and this, if you can notice, it's very similar to the impedance. So this is an increase in functional residual capacity. Globally, 2.99, so let's say 3 impedance value, you multiply the 2.99 times your reference tidal volume, and that shows you globally how much more volume is kept in the lung residually, comparing the PEEP of 10 to PEEP of 20. So you can imagine 4, if it was 1 up here, there would be an increase of 450. So it's 4, 8, 12. So we literally have about 1.3 liters of more air at the end of expiration. With the patient's size, my big concern is over time atelecta trauma occurring in these regions. Functional residual capacities, impedance equals tidal volume. More impedance, more volume, less impedance, less volume. Therefore, right away you see that all of these are positive. We are recruiting at all levels of ventral to dorsal. Unfortunately, it's not, the majority is up here in the ventral region. I like the fact that over here there's 400 tidal volume more at the end expiration, and this would be very minimal, like 40 cc's. Well, 40 cc's at the dorsal region is better than nothing. Yeah, they suggest doing it in ACPC so you can keep a constant drive pressure, delta P, and you increase it by 2. I've tried it on ACVC, and I find that the results are quite reproducible. Now, we have a plateau of 33 when it was at a PEEP of 20, and we had with 18 plateau of 30. Again, there's a very, very high amount of pleural pressure, I'm sure, because of the guy's 500 pounds or something, 450. I haven't weighed him, but he's well over 400. So also, if you recruit over time, then technically that plateau will also indicate that you're recruiting if it would have been at 30. Over here, I'm seeing that at 20, there's no further recruitment because we see the flattening of the impedance curve. So now that we recruited maximally on PEEP of 20, we're going to actually start dropping it and see where we lose the impedance. And then we just go a little bit above, and that's the optimal PEEP.